Okay, hi, Kelsey. So when I look at this, you asked about all the different kinds of equations and which one do I know how to use. Well, they're all actually the same equation. This first one here is just your base equation. When there is no shifts, when there is no stretches, it assumes that it's assuming there is no stretches. So that is your base equation. Just like in a quadratic function, your base equation is y is equal to x squared. When I look at the next one, y is equal to ab to the power of x. Well, a base exponential function would assume that a, which is your vertical stretch or your vertical compression, the basic equation here assumes that it's 1. It assumes that you have you start at 0 and 1. This one says that there has been some kind of vertical stretch or vertical compression. And if a is a fraction, we've got a compression. If it's a whole number, we've got a stretch. And if it's negative, it means that we flipped our graph upside down. This final one here is just the whole equation written out. It's exactly the same. For example, if I assumed that there was no vertical stretch or compression, a would be 1, so we could just forget about it. C is the horizontal shift. So if there's been no horizontal shift, that would be 0. So it would just be x. And D is your vertical shift. So if there's been no shift, that would also be 0. And we'd go right back to y is equal to b to the power of x. So if I look at this equation, which is number 8, I can see that there has been a vertical stretch. Okay, that your starting point is not 0 and 1. It's 0 and 10. So I know that A has to be equal to 10 because it's not starting at 0 and 1. So the stretch is 10. It's been moved up to 10. So I already know that I have y is equal to 10 times b, which is my base, to the power of x. So how do I solve for the base? Okay, all that I'm going to do is I'm going to substitute in my points for y and x. So I can see my first point here, I have 0 and 10 as a point. So when y is 10, x is 0. Well, I know anything to the power of 0 is 1. Okay, sorry, Kelsey, I misspoke myself there. I'm not going to plug in that first point because that's how we got A. Okay, so now I'm going to go, I have to solve for B, right? So I'm going to use this point here. So now I know if A is 10, because that's my intercept there. So now I have y is equal to 10, because I have a stretch, right? Because this is not 0 and 1. I have a stretch of 10, because this is a 10. Okay, so I have y is equal to 10 times b to the power of x. So now I'm going to plug in this next point, 1 and 5. So if y is 5, this is how I'm going to solve for the base. I have 10 times b to the power of 1. Well, I know that anything to the power of 1 is just itself. So now I have 5 is equal to 10 times b. So now I'm just going to do algebra. Divide both sides by 10. So I have 5 divided by 10 is 1 over 2, or 0.5. So b is equal to 0.5. So my equation for this graph is y is equal to, if b is a half, so y is equal to a, which is 10, times 1/2 to the power of x. So that's all that we're doing. So if I go to the next, sorry, I'm just going to pause this and go to the next. So looking at number 10, so the first question at number 10, they've given me 2 points again. Okay, so remember, I'm going to go back to this equation. Y is equal to ab to the power of x. So if I look at this, I can see that my graph has been shifted up. It doesn't start at 0 and 1. it starts at 0 and 3. So there has been a vertical stretch, a vertical stretch, because that is a whole number. That 3 is a whole number. It's been shifted up by 3. So I know already I have y is equal to 3b to the power of x. Okay, so just like in my last one, I'm going to look at my points and I'm going to plug one of those points in. So I'm going to solve for my base. So if y is 9, okay, and now I have b, and when y is 9, x is 1, so I have b to the power of 1. And you'll remember that anything to the power of 1 is just itself, so I have 9 is equal to 3 times b. Divide both sides by 3. 9 divided by 3 is 3, so my base is 3. So my equation is y is equal to 3 times the base, which is 3, sorry, I'm writing my equations here. So it's 3 is my a, because it's been shifted up by 3. My base is 3 to the power of x. So that's how you would do number 10. So number 14, I can do the same way. Again, remember, I've got y is equal to ab times x. And I look at this, there hasn't been any shift. The graph hasn't been shifted to the left or the right. It hasn't been shifted up or down because when x is 0, y is 1. So in this case, a is actually equal to 1 because it hasn't been shifted at all. So I can write the 1 if I want, but I don't have to because a is 1 because x is 0. I can just write it like this. And now I'm just going to do exactly the same thing that I did before. I'm going to take this equation, plug it in, and solve for b. So when y is 3, x is 1, b to the power of 1, it's just as self. So b is equal to 3. So my equation is y is equal to 3 to the power of x. So all of those last three equations were done exactly the same way. You just have to pay attention to when x is 0, what's y? Because that is going to be your value for a, because that represents your shift. And then once you've got that, all you have to do is take another point and plug it in for y and x and solve for b, and then you can write your equation. Okay, so let's take a look at number 17 here. So they've given us some nice points, and remember our equation is, if I look at this, okay, it starts at 0 for the y-intercept, so there hasn't been, so I can see that where 0 is x, y is not 1, so our a, there has been a vertical stretch, so my a is going to be 16. Okay, and I can see that it's decreasing, so that my b is probably going to be a fraction of some kind, because my base is getting smaller. So all that I have to do is, once I know that my a, or my stretch, is whatever the y is when x is 0, so that's 16. Now I can just plug in either one of these 2 points to solve for b. So I'm going to pick 1 and 8 because b to the power of 1 is easy. So when y is 8, my a is 16, and my b to the power of x, when y is 8, x is 1. I know that b to the power of 1 is just itself, so I have 8 is equal to 16b. So I'm going to solve for b. So 8 divided by 16 is a half, or 0.5. So my base is a half. So my equation is y is equal to 16, because that's what y is when x is 0. My b is 1/2 to the power of x. So that's how I would do number 17. Okay, I hope that is helpful. It's actually quite simple. You remember that all three equations are the same thing. It's just that y equal to bx means that there has been no shift of any kind. When x is 0, y is 1. It hasn't been shifted up or down. There is no vertical stretch. There is no horizontal stretch. So if I have y equal to a times bx, again, it's exactly the same equation. If I have an a, it just means that y is not 1 when x is 0. So a is whatever y is when x is equal to 0. So in the base equation, the a is always 1, so I just don't write it. So these two equations are the same. And if I have y is equal to a b x minus c plus d, all that means is that there's been a vertical stretch and a horizontal stretch, as well as there has been some kind of vertical or horizontal shift. Okay, but I don't actually think there's any questions like that on the test. Okay, I hope that is helpful. Let me know.